I'm going to look at 3 different things that affect amine basicity, and hopefully from here we'll be able to develop a sort of feel for the type of things that can change the basicity of an amine, and then from there on out we'll just be able to use logic or be able to better feel your way out, because obviously this doesn't cover everything. But it'll give you an idea of what sort of things can affect basicity and why. So the first group we're going to look at are things that stabilize the ion of this ammonia. So here's an ammonia and here's a methyl ammonia. They are almost the same except for the methyl group. Well, one is a stronger base than the other. Here's ammonia, it accepts a proton, pKb value is 4.7. Here's methyl ammonia, accepts a proton, pKb value is 3.7. So this is a stronger base than this. And this is because the methyl group is able to stabilize the ion. Anything that can stabilize the ion, whether it be through donating protons or resonance, is going to make it a stronger base. And it's interesting to note that, well, it's important to note as well, that in some mediums like water, so if we think about this logically, if we add another methyl group, it should stabilize it more, another methyl group stabilize it even more. However, as I said, in some mediums, this logically is true if you think about it, but at the same time, as we add more and more methyl groups, it becomes less soluble in water. So its effects of stabilizing the ion is balanced out by its decreased solubility. But that might not necessarily be true in something else, but it's something to think about. As we add more methyl groups or whatever it is we're doing, maybe we can add something that it maybe resonance stabilizes instead of adds methyl groups. That way it's more soluble in water. You see what I'm saying? You kind of have to think your way through some of these things. Everything's not going to be labeled, oh, if you do this, it's going to be this soluble and this soluble. I mean, you could, but it would take forever. That's what I'm saying, is you kind of have to develop an intuition for these kind of things. So that's one thing that can affect basicity. Another, this should be pretty self-explanatory for anything that's involved in an aromatic system. If this is adding to the aromatic stability, like so here, it's not directly in the ring, but it's right next to it, and it can donate one of those p orbitals and make it more stable. If it's protonated, it's not doing that anymore. So what's it going to do? It's going to decrease the overall stability. So this is not going to be a good base at all. Now, of course, that's kind of a review for aromatic stability. Anything that is going to interrupt this little party they got going on here. I mean, unless it's for a good reason. If you're going to interrupt a party, it's got to be for a good reason, right? So this generally doesn't happen that much. It can happen, it's got to be really acidic, but generally not very good bases. And the last thing is hybridization. So here are some very similar situations. You have a nitrogen that's sort of off to the side, and it's got an orbital. This one's an sp3, this one's sp2, this one's sp. When we've got sp3s, they're quite basic, but as we go along or go down this row here and we go to sp2 and sp, the basicity decreases, and this is because the electrons are going to be held a lot more tightly to the nitrogen, whereas here there's going to be some electrons here, here, here. It's got less area in which to get close to the nitrogen. It's competing for space. I mean, that's what I think of it as. It's just a competition for space. You've got some electrons here, here, and here. When it's sp2, the electrons are over here and here. So there's less competition for... This thing has to compete less for space with this stuff because they're already being held quite firmly in this direction with those double bonds that don't move around so much. So it's got this extra space and this extra space over here in which to fill up, so it can get closer to the nitrogen, whereas over here it was being pushed further out. Think of the bond angles. And then of course with sp, they're all pointing in this direction, so it's got all of this extra space in which to approach the nitrogen. And the closer it gets to this nitrogen, the less able a proton's able to compete with for these electrons. They're held a lot more closely. The nitrogen is more positive than a single proton, if you want to think about it that way. So looking at the pKb values, so this is quite basic. This not so much, and this is such a weak base that it's not generally something you would even think of in terms of basic characteristics. Like if you think of hydrochloric acid, you think of the chlorine ion. You never really think of it as a base because it sucks as a base. So this basically is the effects, or some of the things that can affect basicity of amines.